Now considering one example, that means we are trying to design here a main bearing for a stationary slow speed steam engine for following data. So the general dia is 200 mm, maximum load is 80 kilo, that is W, engine speed is in terms of RPM, so it is En. So the first step is to select the data from the handbook, table 24.2, by referring Lingaya volume 2. So the application here is stationary slow speed steam engine, that is the main bearing. So looking into this handbook table, it is a slow speed steam engine. This is a steam engine, it's a slow speed, and it's a main bearing we are trying to consider. So the maximum pressure is 2.75 in terms of megapascal, and diametrical clearance is less than 0.001, and L/D ratio lies between 1 and 2, and viscosity should be 60 centipoise, and the bearing modulus is 285.0. So these values you directly take it from the handbook. So this is what they have mentioned. So this 285 which I have mentioned is in terms of metrics. In SI units it is just 48.4. 48.4 is the bearing modulus into 10 power 9. So the listing the data is the first step. Second step is to determine the L/D, that means D and L values. So selecting allowable pressure. So the allowable pressure is 2.75. We need to consider around 60 to 70% of it. Hence they have taken it as 2 megapascal as the rounded value. So they have considered 2 megapascal. With respect to 2 value, they need to calculate L and D values. As D is given directly, that is 200 mm, L also can be determined from this value. So L is equal to 200 from the that is calculated. If we calculate L/D ratio, it has to lie between 1 and 2 from the handbook. So now it is L1. So it is a recommended value. Next, selecting the oil. So assuming the operating temperature between 60 to 70, here they considered as 65 degrees Celsius, and the viscosity is given as 60 centipoise. So this calculation is required here. 60 centipoise. 1 poise is 0.1 pascal second. 0.1 poise. Again I repeat, 1 poise is 0.1 pascal second. 1 centipoise is nothing but 10 power minus 2 into 10 power minus 1 pascal second, which is 10 power minus 3 pascal second. So 60 into 10 power minus 3 pascal second. So centi means 10 power minus 3 pascal second. So by looking into T0, which is considered as 65 degrees Celsius, from the handbook, 65 degrees Celsius with respect to 60 centipoise. So here is 50, 55, 60. This is the line which means trying to touch. So 60, and the grade of the oil is H. So H is the grade, and that H is nothing but it is an aeroplane oil 100 grade or SAE 60 grade. So this grade of the oil is required for this particular application, SAE 60. Next, we need to check for the oil. To check it whether it is thick or not, we need to calculate bearing modulus. Bearing modulus is the one which we say that it is a calculated one. Calculated is from the data what we have calculated for this problem. So it is nu n dash divided by p. Nu is 60 centipoise, and n dash is nothing but RPM by 60. RPM is given it as 200 divided by 60 RPS. and P is the one which we have considered, that is 2 into 10 power 6. After calculation we got it as 100 into 10 power minus 9. We need to check it whether it is greater or not. As we have recommended value from the handbook is 48.4 into 10 power minus 9 and the calculated value is 100, which is greater, then we say that it is thick film lubrication is possible, hence the selected one. If not, we need to reduce the grade of the oil or change the operating temperature. Next, to calculate heat generated, Hg is equal to mu times of W into velocity. Velocity we know, mu is nothing but from the Mackey's equation. Mackey's equation values for full general bearing Ka is equal to 1.95 into 10 power 11. Delta mu is given. After calculating mu, we get it as 4 into 167 into 10 power minus 3. And we need to take this psi value less than 0.001, hence they are taken as 0.0009. Hg after calculation we got it as 698 watts. Next we need to calculate heat dissipated, which is Ca into Tb minus Ta. Tb minus Ta is T0 minus Ta by 2. Operating temperature is 65, ambient temperature is 25, divided by 2 we get it as 20 degrees Celsius or 20 degree Kelvin, however the units you take, where C is nothing but 11.36 into 10 power minus 3 kilowatt per meter square degree Kelvin. So this kilo and 10 power minus 3 will get cancelled, so it is 11.36 watt per meter square degree Kelvin, and A is 25 into D into L. D and L is 200 mm. So after calculation we get Hd is equal to 227.2. The difference between these two is the amount which is removed, heat which is removed. So Hg minus Hd is 470. That means only a small portion of the heat is being dissipated, whereas there are much more heat to be removed, hence artificial cooling is required. Next we need to calculate the minimum film thickness at its location. This is from the handbook. So by calculating the Sommerfeld number and L by D ratio. L by D ratio is 1, and from the data handbook we can calculate delta at H minimum. So these things are very easy, and oil flow rate and end leakage. So this also can be determined. For this we have an expression Q is equal to delta Q C square N dash L divided by force into psi into CQ. The values for the delta Q is given as 4.3 for full general bearing, and this B value is by D B0 divided by 360. This is required to calculate B by L ratio and delta. For that, if we calculate, we get CQ, which is correction factor, flow correction factor. Once you input is, we get Q value. So we need to calculate the amount of end leakage also. In order to calculate that, we need to know oil flow ratio, which is QS by Q. This can be determined or find from the figure 24.39, which is with respect to S and L by D ratio. We can calculate amount of end leakage, and the last one is the power loss. So here, this problem gives us a brief explanation about the steps which are involved for the design of the particular bearings, and there are much more applications in our syllabus, like rotary compressors and centrifugal pump, and there is one more application also where it is a motor. So these three applications also can be discussed and you refer 7.16, 7.22 and 7.23 to understand these type of problems. These type of problems will be occurred in your exam.